We are going to discuss a question which is there on Leetcode. So the question is that we have a number and we need to determine whether this number is a palindrome or not. So we just need to return true or false. So but before going there, how do you understand whether a number is palindrome? So if you read it both ways, either from the left or from the right, it reads the same. It's 1 to 1 and 1 to 1. Instead, if I would have had a number like 1345, and if I would have read it like this, it would have been 1345. But if I would have read it like this, it would have been 5431. And that is very much not a palindrome. So, so I think this is an easy question. It's very much doable in Python because in Python you have a construct. So you can simply convert a number into a string and you can reverse that string and check reverse that string and check if this string is equal to this string, and if so, if this holds, then the number is a palindrome. So for example, if I have a number 121, I will convert this into a string. I will say, so if I have a number num, I will convert this into a string and then I will reverse this. Let me call this string as s and then let me reverse this. So this is the construct that I am using. So there is no index and comma -1, that is traverse in the backward direction. So this string would now be the reverse string. So let it be r. So if r is equal to s, then this is a palindrome. But this looks like an easy solution. But if we want to solve it without this constructor, without reversing, without converting the number into a string, then we would have to think of something else. So one thing that I can do is I can reverse this number. So how do I do that? So there are two operations. The first one is the remainder operation and the second one is the division operation. So when you take the remainder, so any number n is equal to a into quotient plus remainder. So a number, suppose 1345 is, if I, and one interesting thing to note here is that if I divide a number by 10, the remainder that I get is the last digit. So if I divide this 1345 by 10, then I would get 5. 5 is the last digit. So that is how I can get the digits of this number. So let's start with the solution. So suppose if I have the number 1345, then I would need a list. Let me call it as reverse, where I will store the value. Or maybe a string, yeah, where I'll store this value. So on maybe not, sorry, I'm not converting this into a string. I would need a variable, which is variable, maybe the final variable. So if it's 1345, I will have a remainder and I will also have a quotient, and I will keep dividing this by 10 and taking the remainder when I divide this by 10. So when I divide first time when I divide this number by 10, what I'll get is 134 as the quotient, and what will I get as remainder? 5. Let variable has 5. Then after that, the quotient that I'm left with is 134. Now again, to this quotient I'll divide this by 10, and what I'll do, I'll multiply this by 10 and add this remainder. So what I'll get 54. Here the variable is now sorry what I, so basically I'll just redo this one. Let me just clear the mess. Okay, let me solve it again. So I will have a variable called final. I will have a remainder and I will have a quotient, and let this be my number 1345. Now, now when I divide 1345 by 10, what I'll get as quotient, I'll get 134. What I'll get as remainder, it's the last digit. I'm dividing this by 10, remember. So I'll get the last digit. Final is initially 0. So I'll add 5 to it. Makes sense, right? Now, what I'm left with as quotient is 134. So this becomes my new number. Let me call that as n. So when I divide 134 by 10, what I'll get? I'll get the quotient as 1, 3. And what I'll get as remainder? I'll get remainder as 4. But there's a trick to final. We will multiply final by 10 and then add 4, which is the remainder. That will give me 54. Now what I'm left with? I'm left with 1, 3. Now 1, 3 again I'll divide by 10. What I'll get as quotient? I'll get 1. What I'll get as remainder? I'll get 3. Now final, again we'll multiply this by 10 and add remainder, which is 3. So this would become 540 plus 3, which would be 543. Now next thing, quotient 1. 1 divided by 10, which would give me 0 actually, and the remainder becomes 1. Trick, multiply the final with 10 and add 1. That will give me 5431. And here we stop because quotient becomes 0. So this becomes our stopping condition. Right? Now 543 5431 becomes the number that is there in final. Now this number I can simply equate with my original number, which is 1345. And I can confidently say that both of these are not equal. Hence we conclude that 1345 is not a palindrome based on this equality condition. And hence I can return false. So I believe it was a easy solve. I will try to solve it by both ways and put the link in the description. I'll put the link of the code in the description. So yeah, I hope this was helpful. Thanks for watching.